Warning, our videos are for educational purposes only. They are designed so that you can see one of the possible methods that a licensed and insured contractor might use to perform that type of work. Viewer agrees to assume all risks if they attempt to do the work themselves. This is our website, 2beltworkshop.com. Those buttons in blue, that's where you can find the how-to videos, where we can watch the contractors on how they do those projects on a step-by-step basis. Down below, we have the bonus channels, and one of them is Help Wanted. So if you're a contractor out there and you're looking to hire some help, please consider posting a Help Wanted ad on our website. Up on top, if you could be so kind to click on the subscribe, so this way every once in a while we can send you an email with the listing of the new videos that we have just created. If you're a contractor, consider joining our contractor network so that when people are watching the how-to videos and watching the contractors on a step-by-step basis of how to do different projects, and when they're ready to hire a contractor, that they'll be able to find you on our website, 2beltworkshop.com. Also, when you're watching our YouTube videos, and we just started this website in September of 2020, if you can click on the subscribe button and show your support for our channel at 2Belt Workshop, thank you. Hi, my name is Steve Cavalaris, and welcome to this episode of 2Belt Workshop. Today we're going to be installing a circuit breaker panel, so I'm going to be demonstrating how that's installed. And we also call this a load center as well. And this one here is actually made by a company called Leviton. So let's get ready to install this, and I'm going to show you how I do it Steve's way. First thing we're going to do is we're going to mount our screw, and the screws that I like to use are these here. These are called the lath screws, and we can see that gives us a nice amount of area where it's going to firmly hold the circuit breaker panel in place. For this one, I'm going to measure 6 inches from the ceiling, but when you're doing your own installation, you have to decide what the right height that you need to be. Again, we want to be on the stud. Make sure that your screw is on the stud as much as possible. And here I'm just going to measure 6 inches. All right, now I'm going to hang the circuit breaker panel, and this is a heavy one. All right, now what we're going to do is we're going to take our level and we're going to make sure that our circuit breaker panel is nice and level, and I think we're pretty good over there. Okay, we look just right. And I'm going to add a few more screws, just to be sure that it's in there nice and tight. I'm going to put a couple of more screws up on top and a couple of screws on the bottom. Now, we have to be careful because we've got some holes here, and those holes are for our ground bars. We're going to be installing 1, 2, and then a third one down there. So I don't want to use any of those holes. So I'm going to use these holes over here and get that screwed in. And what I like to do, my way, I like to put a piece of plywood behind the load center to make sure that everything's secured just right.
And now I'm going to put 2 more screws down here. Okay, so now our circuit breaker panel is installed very securely. This is not going to go anywhere for a very long time. And again, I like to put a piece of plywood behind here and mount that to the plywood. You know, I've seen other people just take a couple of pieces of wood, but I think the plywood is the best method for a surface mounted circuit breaker. For this demonstration, we are not going to energize the panel, so this way it's nice and safe for us to do this demonstration. Also, later in the video, I'm going to install a couple of ground bars, and I'm going to do a continuity test. And I thought it would be a good idea to do a close-up on the multimeter that I have here. I have it set at 2,000 ohms, and there's a little symbol on there, a little speaker symbol, and we're going to hear a little tone, which tells us that we have continuity. And here we go. We'll do a zoom in on that. And again, it's set at 2,000 ohms, and there's a little speaker symbol over here. And what's going to happen when we take our leads and we touch them together, we're going to come down to 0. And if I come in close here, you can hear that tone. Again, now we have an open circuit, and now we have continuity. We have a closed circuit. What we're going to do now is take a look at the guts. So if we look over here, we can see that we have the terminals over here. And that's where we're going to land our branch circuits. The branch circuits are not going to land on the circuit breaker. And this is the Leviton circuit breaker, which I'll show you close up in a few seconds. So what happens is, once we land our terminals here from our branch circuits, then when we pop in the circuit breaker, it's actually going to connect our grounded bus bar, and it's going to now connect our hot bus bar. And here's a close-up of the Leviton circuit breaker. So we can see here, you know, it's got a on and off button. And then if we look at the back, this is where it's very different from the other circuit breakers. So if we look over here, we can actually see that's where the grounded bus bar is going to make contact, and this is where the hot bus bar is going to make contact. And all we have to do is, once we run our branch circuits into the circuit breaker panel, then we can come later, you know, after we're ready to start powering up the house, take the circuit breaker, slide it in, pop it in, turn on the power, and you're done. Next step is we're going to now install a couple of additional ground bars, which I like to do. And again, you don't have to do it that way, but I like to do it. I like my circuit breaker panels to be extremely neat, and I'll show you how that helps to keep that process neat. Right now we're going to be installing some additional ground bars. This is a torquing screwdriver, and if you happen to look at any of the instructions that you open up the package and you throw that piece of paper away, it's going to tell you, you know, what size screw and, you know, where you need to set your torquing screwdriver to. All right, so I'm going to install 3 of these. I'm going to install 1 ground bar up here. I'm going to install 1 over here, and then I'm going to install 1 down here. All right, so let's do the easy one first. So I have my my torquing screwdriver set to the manufacturer's instructions that came on this. We'll get this in here. And again, it's really important that you put some pressure on it, because as you're putting this in, you're actually threading the hole inside the metal casing of the circuit breaker panel. So I'm not going to tighten that all the way. Right now I'm just going to get this in place. And you're going to start hearing a click pretty soon. See that click? That means that I've reached a proper amount of torque. So there's no reason for me to make it any tighter than that. And there we go. It's a great tool because you don't want to make, your screws a little bit too loose. You don't want to make them too tight. You want to make them just right. Okay, so I'm going to install the other two ground bars. All right, so we're going to install the ground bar here on the top left side. Again, you don't have to install these additional ground bars. I just like them. It makes the job look a lot neater. This way we don't have the the ground wires moving all around the panel. Once you bring them in, you land them right away and you get them out of your way. And again, we're going to hear that torquing screwdriver clicking a little bit. There we go. It just clicked. Okay, there we go. All right, so now we're going to install our my third ground bar. Remember to use force because now you are threading that screw into the sheet metal at the same time. And now we're good. So now we've got our three ground bars in here, and we're going to get ready for the next step. Now we're going to do something that I'm sure you've done thousands and thousands of times before. We're going to be installing our Romex connector, and I'm going to bring in a branch circuit into the circuit breaker panel, and I'm going to show you how I land the conductors, and then we're going to pop in that circuit breaker and to show you how it's done on the Leviton load center. And here we go. Okay, so I'm going to do something I know you've done maybe thousands and thousands of times, more times than you can count. The way that I'm going to strip this sheathing, I'm actually going to pull them apart from here. But what some electricians do, they take a knife and they cut it here right in the middle. But what I've seen is that sometimes the knife slips and it actually slides into one of the conductors, either the hot or the grounded conductor. By doing it this way, I know that I'm never going to have a problem. I just give it a little bit of a twist, and I just pull them apart like that. I grab all my conductors, and I strip it back. We have to leave at least 1/4 inch inside the panel. I like to leave a little bit more because I want to see the color of that cable, and I know in this case, it's a 20 amp conductor. Going to pull on it. Okay, so we're good. I installed a ground bar down here, and the reason that I did that, I don't want these ground wires flying all over, the circuit breaker panel. I'm just going to land it here and make it nice and neat and tight. And I'm going to start this one here. I'm going to start this one here in the middle. I'm going to bend it over to where I think I'm going to want it to be. Over here. Okay, we have our nice click there from our torquing screwdriver. Now what I do here is, I have a little piece of the sheathing, and I wrote a number on here, number 41. I wrote it on both sides of that. So what I'm going to do is I'm actually going to slide this over my conductors. And the reason I do that, in case in the future, if anybody's ever working on this panel, I have a little number on there, and we're going to have our directory, and that's going to tell us, what circuit that is, in case, again, anyone's doing any work on this in the future. And if you look really close over here, you can see, I don't know if you can see that, but there's a little N in there that stands for neutral. And if you can see the color on this screw versus this one, this neutral is silver, and the hot terminal is brass colored. All right, so our white conductor is going to go on our silver screw, and our black conductor is going to go on our brass screw. And again, you really good idea to use wire strippers. I've seen electricians use the linesmen, and it's not the right way to do it. The wire strippers are specifically designed so that they don't cut in to the wire that eventually could damage that wire and make it break. Okay, so we've just landed our branch circuit here in the panel, and we can see that everything's nice and neat and tight to where it needs to be. And now we're going to take our circuit breaker and we're going to pop that in. Turn on the breaker, and we're done. So that's just how easy it is with this Leviton load center. Again, it's very different from what we've seen in the past. All right, so before we actually close this up for tonight, I'm going to do a continuity test, and I'm also going to show you the unique bonding jumper that comes with the Leviton load center. And we all know, if we see that green screw inside the circuit breaker panel, that it's actually bonding the neutral to the ground. They're bonded together. But in this case, it's a little different, but it's the same. Okay, so what I'm going to do first, and I always do this on all of my panels that I install, I'm going to start off at my ground bar here, and I'm going to go ahead and touch, the other ground bar, and I see that we are electrically connected. I'm going to go to the other one, and I see that we are electrically connected. And I'm going to go to the bottom one now, and we're electrically connected. Now what I'm going to do is I'm going to go from the ground bar here to the neutral bar, and let's see what happens. Nothing. I am not electrically connected here. And that would be the case if this was a sub panel. We're not allowed to bond the neutral to the ground if this is a sub panel. But if this is the first panel, the first point of disconnect, we have to have our bonding jumper in there, and that's what it is. That is our bonding jumper for the Leviton. So where this goes, it actually goes here. So we have to remove this screw from here. And we're going to take our other green screw. We'll put it over here. And I'm not going to tighten this all the way. I'm just doing this for demonstration purposes. Now we're going to see if the ground and the neutral are electrically connected. So here I have one on the ground and then one on the neutral. And we can see here that we are electrically connected. So when doing the Leviton panel, that is your bonding jumper. So again, if that is your first point of disconnect coming into the house, you'll need that. But if it's a sub panel, then no, you don't need that. You want to make sure that that is separated, because we can have something called objectionable current. And that's when, if we have our first point of disconnect here, where the neutral and the ground are bonded together, nowhere else in the electrical circuit throughout the house or any sub panel, any electrical box, any receptacle, any switch, can the ground and the neutral be bonded there. Because what's going to happen, as the current's going back on the white wire, now it's also going to come back on the ground. And now we don't have what's called the canceling effect of the magnetics of the currents, from the hot and the white. Basically, they cancel each other. And that actually is part of the theory of how a GFCI works, by the canceling effect. So again, if you open up a sub panel or you open up a receptacle, if you see that ground and neutral bonded there together, that's a bad thing. You need to disconnect them, because again, the only place where that can be bonded is in the first point of disconnect. Again, if this was the primary panel, we'd have our bonding jumper and that'd be fine. But this is being demonstrated as a sub panel. So outside the building, there would be a disconnect, and that's where we bond the neutral and the ground together. Very important. So the next thing I'm going to do here is I'm going to pop in some circuit breakers. And again, remember that in the Leviton, we actually land the conductors right on the terminals here. So if you could just imagine that there's other conductors landed here, and now you send out your journeyman out to the job site to install the breakers. So let's see how long it takes to install 10 single pole breakers plus one 2-pole breaker. And here we go. And again, as I'm doing this, I'm going to be looking at the colors of the conductors, of the little tab that I put there, so that I know if this is a 15 or a 20 amp circuit. Okay, now here's our 2-pole circuit breaker. Okay, that's how fast that one goes. So, if you send your journeyman to go ahead and pop in the breakers and start, turning on the circuits, and they tell you, oh, you need the whole day to do that, I think here, my opinion, is that this Leviton panel is a real time saver, as far as this aspect is concerned, that you could make sure that, at the time of the rough-in, the conductors are landed. And the number one problem that I've seen in the field is that people don't, sometimes label, all of those branch circuits hanging down on the floor. I think it's just a lot nicer. Land them on the rough-in and then mark them. And then when it comes time to power up the house, you pop in the breakers, turn everything on, make sure that everything's good. All right, I am going to install another circuit breaker. But you might be saying, hey, Steve, you've already installed so many, why do another one? Well, this might look the same, but it's different. Let's take a look. This is a dual function AFCI, GFCI circuit breaker. But it might be looking a little weird right now because there's no test button over here. What Leviton did, they actually combined it into the rocker switch. So what happens is we actually click it to the off test position, and then we want to test it. We put it back on, and if it holds, that means that it's working. But now we can see I'm trying to press that button, and it won't let me turn it back on. That's because the circuit breaker is not powered up. But now let's say it's powered up, and we try to turn it back on. It's not letting us. So it either could be that we have a problem with our internal wiring in the house. We could have something called objectionable current, or it could be that the electronics got toasted in this AFCI, GFCI device. And we see this a lot of times with GFCI receptacles. You know, we're supposed to be pushing that button once a month to test that GFCI receptacle. You know, you'll find this in kitchens, you'll find it in bathrooms, you'll find it in basements. You'll find the GFCI receptacles outside, in a crawl space. Basically anywhere where there's water and people and electricity, you're going to have GFCI protection. Either, you know, from the branch circuit, from the circuit breaker, or at the point where there's the device. Very important. And I can't tell you again how many times I go in and press that button on the GFCI receptacle, especially the older ones, and they don't work. They don't shut off the power. So it's giving a false sense of illusion that they're protected. In the meantime, what's happening is that defective GFCI receptacle is providing unprotected power. For us electricians out there, we all know about the dangers of, you know, people getting shocked or electrocuted. And the GFCI was designed to save lives. The Leviton circuit breaker was designed so that it won't turn back on if there's a problem. You'll have to find where that problem is, and if it's not a problem in your wiring, then, you know, there's a chance that somehow the electronics got toasted on this, and you're going to have to put in a new circuit breaker to provide protected power to that branch circuit. So let's pop this in to see if it's any different than the other ones, and it pops right in. So, you know, from my perspective as an electrician, you know, once we land the conductors, one on the neutral and one on the hot, there's no additional wiring that has to happen on this special circuit breaker, which is a nice savings of time. So as you can see, we've installed the cover to the circuit breaker panel, and you might be asking yourself why you can still see, you know, the inside where we can see the circuit breaker over here. Well, this is an optional cover that Leviton sells, you know, with the clear plastic. And, you know, the nice thing about this, you know, for the homeowner, you know, they could be passing by, you know, their circuit breaker panel, and they could notice that maybe one of the breakers has tripped. You just have to be careful that the electrician installing it, make sure they clean their hands, because you don't want to have all kinds of dirty fingerprints on this. But I think it looks really cool. The other thing here, and Leviton is actually making a change from what I understand. They're actually going to have this top part is solid, and what that's going to do, it's going to allow to put the directory up here. So, you know, that's actually a requirement of the National Electrical Code. That directory needs to be in or on that circuit breaker panel. Also, they do have another option here. If you want to, you know, leave it like that and not have the directory over here, they do have a strip of paper that gets attached to the middle, and that's where you could write down all of the circuits. But you know, make sure you have good penmanship, because you don't want to have your electrician who's, let's say, has a pen or a Sharpie that's real dull and you know, make a mess of this. This is a really elegant looking panel, and I think it would look nicer, you know, if you got the one that had the solid piece over here. So when you close the door, you know, you don't have to see the main breaker, but then you can see all of your breakers here, and you can see, you know, which one has tripped. And I think it's a nice little addition. So that's the summary of the Leviton Load Center. We hope you enjoyed it. We certainly had a lot of fun looking at this and finding out about all the new things that they came out with their new load center. Again, on behalf of Two Belt Workshop, my name is Steve Cavalaris, and thank you.